So let's start with two atoms. Let's make them oxygen to be easy. We have 6 total, and the second one over here. And we're going to see how they're going to share.
Whoa. Listen. I don't mean to be a pain, okay? But I'm really lost right now. And I'm hoping that you can slow down, you simplify your terms, clarify a bit, summarize, because I feel like I'm trying to hack my way through a jungle with a butter knife right now, okay?
Well, let's see. Atoms want to have 8 valence electrons in the outermost ring, so they would share with one another in order to achieve that number.
Students will often ask for summaries of the material. This is due to the overwhelming workload they are given in school and their desperate attempt to organize it into easy-to-comprehend chunks. It is very important to try and see it from their perspective. Because you know much about the subject and have much to say on it, but in making it easy to comprehend for them, do your best in narrowing it down to the most crucial components of the material. To help you do that, ask yourself questions like what, when, where, and which. Try to answer them in the shortest possible way that still represents the correct concept. If there is a keyword, emphasize it with intonation.
Oftentimes, confused or frustrated students will say that they just don't get it, that they just don't understand the topic at all. Usually this is not the case. Next time a student says something like this, try to coax out of them what in particular they are confused about or where in their lecture the confusion began.
Whoa. Listen, I'm completely lost right now, okay? I don't understand. I'm not speaking for everybody, but this isn't making any sense. I'm hoping you can slow down, simplify your terms, clarify, summarize something, please.
Can you point out anything in particular that you're confused about?
Yeah, okay. With the citric acid cycle, I'm just not sure how the electrons are moving from one chemical to the next. Like, what causes it?
Okay, that's a little easier question to address when you put it more specifically. Please, everyone, be as specific as you can with your questions. So, electrons try to move from a higher to a lower energy state, and a chemical would share an electron with another chemical if that would make it more stable than its current chemical host, and that electron would jump to it.
Any students taking an introductory science class at Stony Brook will have some background, though it may not be deep. When attempting to explain something to a confused student, ask them what they have studied before in this area and try to expand from that point.
Okay, can I just stop you again for a second?
Sure.
Okay. How is it that the cycle just keeps going on and on that way without any end to it?
What have you studied in biology or biochemistry that you think relates to this?
Well, the mitochondria in high school, powerhouse of the cell, you know?
Then you're surely familiar with the electron transport chain, which gives me some insight as to why you might be confused. We'll be learning more about the electron transport chain later on this month. So you're surely familiar in the chain that there's a final electron receptor, oxygen, which turns into water.
If the student doesn't have enough science background for you to make a connection to, use an analogy from everyday life. You probably realize that the laws governing the flow of electrons through a conductor are similar in some ways to those governing the flow of water through a tube. When you first learned about the flow of electrons, it of course would be helpful to draw on your common sense knowledge of fluid mechanics as an analogy. Try this with your students.
You're really blowing my mind, man, okay? How are the electrons moving around like this? I don't get it.
Okay, imagine holding a marble on the rim of a cereal bowl. If you let it go, what will happen?
Well, obviously it would roll to the lowest point in the bowl where my Fruit Loops get soggy and unappetizing.
Correct. Each successive chemical is like a lower and lower part of the ball. The marble will keep falling to the lower points, and the lower points are measured in a chemical by their reduction potential. The higher reduction potential, the lower points in the ball. So the electron moves, as the marble would, to chemicals with higher reduction potential.
You're good. You're good, you. You're good.
Okay, I'm good.
When explaining something, it is important to know whether your explanation is making any sense to the confused student. Simply asking, "Is this helping?" or "Is this making more sense?" while you explain will help you explain it more clearly or using different examples. It better connects you to the student's confusion and whether it is dissipating.
The arrows leading away from the cycle, those chemicals have some kind of a function in the body, or are they just byproducts like carbon dioxide?
Good question. As you can see here, a acetate leads away from the cycle. The carbon dioxide is released as a waste product, but acetate can be synthesized into an important amino acid called asparagine. Does it make sense?
Yeah, okay. What about the rest of the chemicals, though? Do they all have a function?
They all have functions in our body. There is another example.
It's important to review difficult topics before moving on to a new one. A great way to reinforce what your students are learning is to make a PowerPoint slide that gives a simplified picture of what you just showed them. This suggestion is particularly good if you are short on time. You can tell students to wait to ask questions until after you've shown them the review slide, in which case they might answer their own questions.
I just had a question about acetyl-CoA. Could you go over the function of that one more time?
Sure. Before the exam, we will review the topic before we move on to the next. Can you hold your question?
Yeah, okay.
Horatio, do you still have a question?
Oh, no, I think I understand now.
Okay, so could you tell me what is acetyl-CoA and what it does?
Okay, sure. It's the initial input into the cycle, and it's ultimately transformed into energy. But what I was confused about was whether it had some kind of catalytic function, but your review answered the question for me.
Remember, be patient with your students and try to understand that they may not love your field as much as you do. Do your best to make them love it by making it as easy to understand as you can. Asking for specific questions, drawing on your student's background, making analogies, asking for feedback while you answer, and making summary slides are a great way to field or even preempt your students' questions. Good luck!